In this video, we'll continue working on this bearing wall. So we're going to start adding some of the top plates across the top here. I'll do this by copying one of these and copying it up to the top of the studs. So I'm going to go to section number 1. Okay, now one thing that we'll need to do, if you go to level 1, and if you haven't done this already, if I click on that section, if it is stretched all the way back to here, when I go to section 1, it's going to show all the framing in the distance. If I don't want to see all that framing so I can isolate what I'm trying to do, I'm going to go back to level 1 and pull this closer in so I'm not seeing this line of studs in the background. So go back to section 1. And this is the plate that I'm going to copy up. Oops. I come in a little closer, copy, and my dimension is going to be the stud height plus the thickness of a plate. So I'm going to do it at 41.125 inches. And let's see how it is. Okay. Now, for these top plates, they can stretch. They need to stretch all the way across. Oops. So I'm going to click on it and I'll grab having some issues here. I'm going to stretch it all the way over and grab that little triangle, pull it across. And when I get a little closer, I will use the Align tool to bring it the rest of the way. Let's do that again. Align, pick. I can do either edge of these plates here and bring that over. Okay, so now it's stretching all the way across, and then what I can do is make another copy 1.5 inches above that, and it'll just sit right on top. Okay, so now we've got the double top plate along the top of the bearing wall. Now this rectangle right here is the opening for the door. But one thing we have to keep in mind is that this wall is a bearing wall, meaning that the loads from the floor above are resting on the wall. And right now, with just this double top plate, I don't have enough structure to take the load of those floor joists that are going to rest on top of this section right in here. This would start to sag and potentially fail structurally. We need to put in something called a header. So here's a page of your textbook. And what we see here are a series of openings. Here's a door opening. Here's a window opening. At the top is a header. So again, you need the header to carry any kind of loads that are being transferred from above. This header, as is noted here, is a sandwich of 2x members. So they are going to be 1.5 inches wide, plus a 1/2 inch spacer in between them. So 1.5 plus 1.5 plus 1/2 inch gives us a 3.5 inch dimension. You want the faces of these members to be in alignment with the face of the studs. Now, in this case, above the header, we have something called cripple studs. Sometimes you'll see these, sometimes you won't. Sometimes they just make a slightly deeper header and eliminate the cripple studs. It's perhaps more material usage, but it could also be less in terms of labor. So here's an example of a header that has no cripples. You just see the double top plate up here. This is going to be what we draw in ours. We just don't really have a sufficient dimension to go ahead and add a header plus the cripples. So we'll do a detail that looks something similar to this. So to illustrate a little bit about how I came up with some of the numbers that we're going to be using, this is the wall section that we've been looking at previously, and I made a copy of that so I could look at the dimensions needed for the opening. So typically for residential architecture, doors are going to be 80 inches, 6'8", or so 80 inches equals 6'8", or 7 feet. In this case, I'm going to make the rough opening set for an 80-inch door. So you'll see that these dimensions are a little bit more because you need space for the jamb and for some shimming. So it's going to be slightly larger than the 80 inches that the actual door panel might be. We have a couple of plates up here, top plates, and then we have a header that's going to be located over the opening. So in this case, this dimension is not quite right. Let me fix that. So what I have here, when I take this 97.125, which is the space from the subfloor to the underside of the joists above, I'm going to take that 97.125 and subtract the necessary rough opening that I need for my door. I'm going to subtract the two top plates they're 3 inches when you add them together. And what I'll end up with is a dimension that would be appropriate for the header. It's a little bit bigger than the standard dimension lumber, but this will work fine for our purposes. I'll just have a slightly larger rough opening. Now, looking at one of the pages of your textbook, you'll notice here that the boards and dimension lumber have a nominal size and an actual size. So, we've been using 2x4s, which are 3.5, 2x6s, 5.5, etc. Once we get up to 2x8s, it goes from a 1/2 inch increment to 1/4 inch. So we're going to be making that header out of 2x12s, which are 11.25 inches. So I'm back in level 1, and I'm going to add that header in this zone right here. I'm going to go to the beam tool under structure, and I'm going to edit the type. I'm going to duplicate this, and I'm going to call this a 4x12 header. And I'm going to say, okay. Okay, that dimension will stay the same. I'm going to change this dimension here to that 11.25 or 11.25 inch dimension and say, okay. Now, I want to take a look at a detail before we proceed on with this next step. You'll notice that the header rests on one of those studs. This is called a jack stud. Right now, we've got our two studs both going all the way up to the top plate, but we need to bring them down. So I'm going to do that first before I begin adding the header. So I will go to the south elevation, or no, I want to go to section number 1. And I'm going to click on this column, this timber column 2x4, and I need to make some adjustments for the top offset. I need to add an 11.25 inch dimension to that. Okay, now it's going to continue to be this negative value because I want it to be below level 2, but I'm going to change this to 2 feet 5 inches. And I'll do the same to the one on the opposite side. To get rid of the 3/4 and apply. All right, now I'll go back to level 1, and I will go to structure beam, and I'll add that header, and I want the header to go from the middle of those two. Looks like I'll have to use my alignments. Let's see how it looks in the section. Maybe we can complete it there. You can see it's been placed below level 1, and I want it to be above. So I'm going to make this start level 94.125 inches, and the end will be the same. Okay, so now it's sitting on top of the jack stud, but below the plate. Okay. So that concludes what we'll be doing for that bearing wall that's running across the middle of the structure. Let's take a look at how everything is in 3D. And that's it.